So let's look at question 2. I'll assume, of course, that you've already read it. And we've got this little table here, and it says here's the number of premium ingredients that you might choose and the probability that people choose them at. So in other words, if you had 100 random customers, we typically expect about 42 of them to choose no premium ingredients, 33 of them to choose one, and 3 out of the 100 to choose 4. So it says on part A, what's the probability a randomly selected customer selects 2 or more premium ingredients? That's the sum of these 3 numbers right here. So you can add up 14, 8, and 3, and that's 25%. As before, I'll show you the written solutions in just a second and give you some ideas on the grading of that, or potential grading of that. If a randomly selected customer selects at least 1 premium ingredient, what are the chances he selects 3 or more? Okay, so what we're saying here is we're giving you the fact that they're one of these people. How many people are here? 58% of them, because that was 42. So 58. So out of the 58, which ones of these selected 3 or more ingredients? That's these two, 8, 9, 10, 11. Whatever 11 out of 58 is, that's the answer right there. I suspect you'll be able to even leave it as this, but of course a 4-function calculator or a simple calculator will even work that out. What's the shape of this distribution? Well, I kind of turn my head to the right so that 0 is now on the left, sort of rotate that around and make a little histogram in my mind and see that this is a right skewed distribution. So it says, explain how you arrived at your decision. Well, that's because these smaller numbers occur a lot more frequently than these larger numbers, which makes it into a right skewed distribution. So now we have the mean and the standard deviation, and it says if 16 customers are chosen at random, describe the shape of the sampling distribution of the sample mean number of premium ingredients, and of course explain how you arrived at that decision. Well, all it says on this question is talk about the shape. And we already said the shape of this distribution was right skewed, but if I take a sample of 16, what do you think? I think this is a great question because we frequently fall into this pattern of everything's normal, everything's normal, everything's normal. We kind of checked out and saw this wasn't normal, but I bet this is. Actually, it's not. Sample size is not very big here. 16 is not a very big sample size. So my distribution is still going to be right skewed. It'd be fine to say it's less right skewed than before, but it's still going to be a right skewed distribution. So now letter E says a shift leader wants to use a random sample for Saturday to plan orders for next week. What's the problem with this? Well, the problem is Saturday may not be representative of a typical day. Saturday's orders may not be representative of the rest of the week. So we've got some bias, a systematic favoring of a certain outcome, and it just says, do you think whether this will be an under or overestimation? I think the big idea is not whether you say under or over. It's not like one of them's correct and one of them's incorrect. It's whether you've got an explanation of what it might be and you connect that to under or over. So perhaps you say Saturdays aren't quite the same because people go out and they spend more money and they're having a good night out because it's the weekend. Well, in that case, people are buying more premium ingredients, which means I'm going to overestimate what they might buy on a regular weekday. The next question says, we've got 300 orders with premium ingredients having a profit of $2. What's the expected profit on a Friday night? Well, we know that the average number of premium ingredients per order is 0.97. So if she took 300 orders with an average of 0.97 per 300, multiply those, and then multiply that by $2, says you can round the values to make it easier to do without a calculator. That's something we may see on this year's test. So just make that 1. That's an average of 3, or an expected number of 300 premium ingredients. That's about $600. Be sure you put it in context, $600. Now for part G, it says she took a larger sample. She took 50 weeks in the year and selected 2 orders from each week. That gives me a sample size of 100. What's the sampling distribution here? Well, the sampling distribution is going to have the same mean. That part doesn't change. It's still 0.97. The spread is going to be, we've got a very large sample size, so the spread is smaller, but the shape is approximately normal. The standard deviation before was 1.072 divided by the square root of n. Well, this is 100, so that's easily square rooted, so that's 10. 1.072 divided by 10, 0.1072 will be the standard deviation. I'll show you that printed in just a second. What do we call this sampling method? This is a stratified sample. The stratas are the weeks, and an advantage of doing this is because people may not buy at the same rate on all the weeks throughout the year. So if people buy more in the summer in this restaurant and less in the fall, or if Christmas is a time they buy a lot there, whatever it is, that variability that occurs throughout the year will be accounted for in a stratified random sample. Finally, I says the weekends are really different. So what kind of method would I want to use to adjust for that? Again, a stratified method would do that, where I could guarantee that my sample was spread out throughout the week. And that would be an advantage over a simple random sample. So let's see what this looks like worked out. Again, there's part A where I added up those numbers. In part B here, I'd love to see this answer written in context. This one as well, I think a good quick sentence where you've put it in context is always a great idea. What's the shape of the distribution? Again, it's skewed right, and they said why here. It must be in context, and explain that higher values occur less frequently. For part D, if you said it was normal or approximately normal, you don't have it. It's not. It's still skewed right. It's just less skewed right than it was before. Letter E, they said no, correct answers should include a reasonable characteristic of how Saturday night customers are different. Your explanation may be different than mine, and you may even assume the bias is going the opposite direction, as long as you've understood that there could be a bias that Saturdays are not representative, and here's what it might do to my estimate. On letter F, Mr. Dirksen said we wanted to have a dollar sign on there for full credit. Great idea. We don't want so-called naked numbers. We always want context, units if they exist. Dollar signs are great. Letter G, there's the mean, 0.97. Standard deviation, they've showed a little work. Might show a little more on that. The shape is approximately normal. Perhaps even say because of the large sample size on there. And he said that we want to make sure we say that the shape is approximately normal, not normal. It's not normal, it's just close to normal, and pretty close to normal. For letters H and I, you can look at those explanations and see what he's written for those. Now again, this is just an idea of what a test might look like. I think these questions might be a little longer than what you'll see on the actual test, but it's a good idea to get used to pacing that, and it's a good idea to use your time to write context, to write explanations, to really help the grader see into your thinking. Hopefully this helps.